Hello geometry students and welcome back to another video lesson on trigonometry. Today we're going to focus on setting up and solving trigonometric ratios that will help us find missing angles inside of a right triangle. So we're going to focus today on that missing angle. Before we do that, I've got a couple of warm-ups that I would like us to try, where we're going to try and find the cosine of 30, the sine of 30, and the tangent of 30 in this triangle, the sine of 45, the cosine of 45, the tangent of 45 in this triangle. Now, the small hiccup, the small problem might be they've only got one side of the triangle labeled for us. What do we do? Well, here's your hint. These are special right triangles, 30, 60, 90. And there's a relationship in that 30, 60, 90. If this side is 5, the hypotenuse is 10. And if this side is 5, the adjacent leg here is 5 square roots of 3. Whereas over here, it's a 45, 45, 90. So leg and leg are both 5. And the hypotenuse is 5 square roots of 2. So that should help you figure out the sine, cosine, and tangent of each of those. Go ahead, pause the video, and take a shot. The sine of 30, right? So now we're working with 30. This is the opposite side. This is the hypotenuse, and this is the adjacent. So the sine of 30 is opposite over hypotenuse, which is 5/10. But we're going to simplify that into 1/2, the fraction 1/2. No decimals. We're not doing anything with decimals. The cosine of 30, cosine adjacent over the hypotenuse. So the adjacent side is 5 square roots of 3 all over the hypotenuse, which is 10. But we can simplify 5/10 to be 1/2. And we'll put the square root of 3. We'll leave that up on top. And then the tangent of 30, O over A, the opposite, 5 over 5 square roots of 3. So the first thing you might recognize is I've got 5 and 5. So if we cancel those, we are left with 1 over the square root of 3. But we cannot leave the square root down there, and we do not want decimals. So we're going to multiply by square root 3 over square root 3, which turns into square root of 3 all over 3. Right? The square root of 9 on the bottom turns into 3. So that's for the 30, 60, 90 triangle here on the left. Now let's take a look at the right. Here's 45. We're going to use that one the whole time, which means this one's opposite, this one's adjacent, and this one is our hypotenuse. This one's going to have a little bit more work involved, unfortunately. The sine of 45, so O over H. Opposite is 5 over the hypotenuse, which is 5 square roots of 2. The 5s will cancel, and we're left with 1 over the square root of 2. We cannot leave it like that, so we rationalize to get square root of 2 over 2. Here's the nice part. Cosine is the adjacent over the hypotenuse. But the adjacent over the hypotenuse is 5 over 5 square roots of 2, which was the same thing we just did. And so it's going to be the same answer, square root 2 over 2. And the tangent, opposite over adjacent, which is 5 over 5, which is just 1. Right, which is just 1. So occasionally you might have to go back and use some of these 30, 60, 90 rules to help us find some of the missing sides before we can apply trigonometry. We've got 2 examples today for finding missing angles. That's it. A quicker video, I think, because it will be rather similar to what we did yesterday. They're going to mark an angle, in this case down here, theta, or an x or something, and ask you to find that angle measure, which means that's where we're standing. We are standing right here. So based upon standing there in that corner by theta, what would we label 8? That's the opposite side. And what would we then label 11? Well, that's the hypotenuse. So which one of my trig functions uses opposite and hypotenuse, O and H, sine of our angle, which is theta, equals the opposite over the hypotenuse? And then we fill in what we know. The sine of some angle, we don't know the angle, that's what we're trying to find, equals the opposite over the hypotenuse. Okay? If I want to get the theta by itself, I've got to somehow undo this sine. Well, this operation is called sine inverse. If I do that to one side, I've got to do it to the other. Sine inverse. The inverse is like taking the opposite. The sine inverse cancels out the sine, and we're left with theta equals sine inverse of 8/11. Now, this is a topic in a section where we will have to use a calculator. I'm going to put in the directions here, round to the nearest tenth. Right? We should have in those directions that you're going to have to round. And we're going to go to Desmos and find that function, sine inverse of 8/11. You'll notice once you get to Desmos that it's not here on the main panel. You've got to hit this function button right here, and then sine inverse is on that function panel. And we're going to hit sine inverse. Now I don't have the numbers anymore, so I'm going to go back to the main and do 8/11. 46.7. 46.7. So theta equals 46.7 degrees. So it's very similar to what we did yesterday. We start by identifying which angle are we standing at and how do we label the sides that we're given. Which trig ratio is that? Plug in what we know. The only difference here is that if I have sine of an angle, in order to solve, I use sine inverse. And then we will round to the nearest tenth. So if this angle down here was 46.7, hopefully we could now figure out this last angle down here, knowing that all triangles add up to 180 degrees. Why don't you try this last one? See if you can't find the measure of angle X in this triangle. So if I'm standing at X, all right, so I'm going to just circle down here. I'm standing here. This side is opposite. This side is next to it, so it's adjacent, because this one was our hypotenuse. What they give us to work with, though, is the opposite and the adjacent. Opposite and adjacent is tangent. So tangent of our angle, tangent of some angle, equals the opposite over the adjacent. And let's plug in what we know. We don't know the angle. I mean, we could change it to an X if we want because it's labeled X. We don't know it yet. Equals the opposite, which is 18, over the adjacent, which is 15. To get X by itself, we would have had to take the tan inverse of both sides. So X equals that tan inverse of 18/15. So I'm going to go back to Desmos. I'm going to grab this function one. The tan inverse of 18 over 15 is 50.2. X would equal 50.2 degrees. All right. So the only thing that really changes is that we have to use this inverse, tan inverse function, the opposite, to help us find the actual angle measure. Tan inverse, cosine inverse, sine inverse. That helps us find angle measures. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.